Good. Thank you for watching this channel. Now this channel is now 137th videos to date since its launch in December last year, 2024. Excuse me. So this channel really growing very good, very fast. So thank you for everyone subscribe this channel. So if you haven't done so, now it's time to subscribe this channel by clicking the bell button so you can access all those 130 plus videos easily. So please take advantage of that. Thank you. All right, today we're going to do a function in written as piece and y function. So we got two functions. One is a linear and the other one is obviously reciprocal function like a hyperbola. So this function to be continuous, so because there's a domain is different. So the first domain is x when it belongs to negative infinity 1, and the other one is x greater equal than 1 to the positive infinity. So this is a combined two functions together. So we want to ask you what is the m and n, so that these two functions, one is a fx, one is a derivative of function, continues over this domain R. So how do we do those two functions as a continuous function? So let's do the first fx first. So for x to be continuous at x equal to 1, so that means the x equal to 1, we're using, my apologies, here should be 1. So x equal to 1 belongs to second domain. So we substitute for equation number 2. So the answer will be f2, f1 is 2. So for those two functions connecting together at x equal to 1, so that means m, so if I replace x with 1, the first equation, so the f m plus n must be equal to f1, which is the second equation. So therefore, we receive this equation, m plus n equal to 2. So this is from equation number 1. So we still don't know what m and n is. So now we're going to do second, we do the first derivative as well. So we differentiate the function fx in relation to, so when first we do in domain at, so x is the second domain. So we differentiate that. So we substitute x equal to 1 into f derivative function. So when you do differentiation of the 4 divided by 1 plus x squared, I'm going to turn to the negative 1. So therefore, I'm easily. So I avoided to use the quotient rule. So we substitute into the function, derivative function with x equal to 1. So you receive the f dash 1 equal to negative 2. Now, if I'm going to use the derivative of function at less than 1, so for x less than 1, which is from negative infinity to positive 1, so my second gradient, so the two gradient must be equal. So that means the second function, the gradient is m. The first function, which is in the first domain. So we know this is a gradient of the function as linear. So this is the n. Must be equal to the gradient of the function at x equal to 1. So therefore, my 2 gradient must be equal. So the m must be equal to -2. So if I m equal to -2, we substitute into equation number 1. So we have the n is +4. So we confirm that's the case. So which is a pretty interesting question. So we got 2 different domains. We're going to do 2 different differentiations. All right, so we know the solve the question A. Now we're going to do the area enclosed to the whole function, graph the function. But the interval is from x equal to 0 to square root 3. So therefore, we're going to integrate this. We're going to find the area of the function enclosed under the curve, which is enclosed with x-axis. So we know the area is 0 to square root 3 and fx with respect to x. So now we're going to divide into 2 different functions. Why? Because of the 2 different intervals. So from 0 to 1, I'm going to use the first function, which is a -2x plus 4, which is linear. So we call area 1. Second one is from 1 to square root 3. We use the second format of the function because we got 2 different equations. So we're going to find the A1, A2 separately. So let's do A1 first, which is pretty simple. We integrate that linear to become -x squared plus 4x, plug in 0 to 1. So the answer is 3. Area 2, we're using the substitution methods. I'll move 4 outside. So I'm going to replace x with tangent theta because we're using trigonometry identity. I think I showed you some time ago. 1 plus trig square theta is secant. So this is a trigonometry identity, very important one to solve for integration problem. So dx will be tangent derivative 10 is secant squared, the derivative theta. So now we're going to change the domain from 1 to x, from 1 to square root 3. Theta will be from pi over 4 to pi over 3. So that's in my new domain. So this is the new domain for theta. So the area 2 will be, because we're using substitution, so I'm going pi over 4 to pi over 3. Then we cancel these 2 out, become 4 theta from pi over 4 to pi over 3, substitute. So the answer will be pi over 3. So therefore, we're adding those 2 areas to get the total area is 3 plus pi over 3. Then common denominator is 3, so become 9 plus pi over 3 units of square. So this is a question regarding the function written in 2 different domains in 2 different equations. I hope you enjoyed it, and thank you for watching. If you do, please give us the thumbs up. I'll see you next video. Bye.